Good afternoon, everyone. It's Miss Steph. Hi. Hello. Hi. Good afternoon. It's Miss Steph. It's good to see you today. Or rather, imagine seeing you because y'all know I can't actually see you. I just have to use my imagination. Important skill that all scientists must have. All right, so it's great to be on with you. And you know how it is. Got to make sure that we're sharing it all across the various platforms and whatnot. I'm going to try to do that a bit faster than I normally do. But yeah, hi. Nice to see everyone. Like I said, yeah, you get my point. But we are live, live. This, believe it or not, is actually episode 53. Can you? I just need you to just absorb that information for a second. This is episode 53. Can y'all be excited with me about that? Episode 53. That is how we have been doing this for a really long time. 53 episodes of Science with Miss Steph. Some stuff has been pop up, some stuff has been Saturday science, but today we are doing our second, can you say second, solutions video. So today I'm actually going to last week I kind of talked about how crystals um, are dependent on a specific way that you make your solution. Okay, and I made some crystals, and I'll actually show you what they look like now a week later, right? From a kit and all that type of stuff. And today we're going to talk about what a solution is, right? I'm going to define that for you, and then I'll show you a little bit about what happens when you dilute that solution. So not only am I going to define solution for you, but I'm also going to give you a definition, let you see a dilution, and then after letting you see a dilution, hello, come on somebody, we are going to talk a little bit about, well, not a little bit about, a lot about how the dilution, okay, can have an impact, right? How you can see how dilution makes a difference. Yes, in your reaction and in the product or in the thing that happens once you've made a dilution, right? And so we're going to have a lot of fun today. Lots and lots and lots of fun today. Once again, it's Miss Steph here. I am the founder and executive director. If you don't know that part by now, that means you've not been watching, which hurts my feelings a bit. But like I said, as I was saying per se, founder and executive director of Triple F Empowerment Inc. We inspire, empower, and encourage young people to go into the STEAM fields. That's what we do, in case you were wondering, or in case you didn't. No. Okay? That's what we do. That's why I come on every Saturday, or rather, as many Saturdays as possible, right? To let you all have an opportunity to be inspired, empowered, and encouraged to go into the STEAM fields. All right. And so for clarity, as far as academically speaking and kind of age group wise, what age group this type of lesson is best for, I mean, normally I like to do stuff for everybody, but this is kind of hitting pocket for fifth grade and up. In case you're wondering, I do want to have, my regulars, of course, join me and have fun with me today. But just so you have an idea ballpark, um, who this lesson might be for, and just so that you kind of get your little ones prepared. If you've got little young scientists watching with us today, just know that they might be kind of you know challenged as far as keeping their attention span. All right. So yeah, we're gonna really go into lots of chemistry today. That's the point. Today, um, really delve into some chemistry terms. Shout out to my chemists that are here and my chemists who support us. I have lots of friends who, over the years, who've supported, who I know from back in my days when I was when I was in the applied scientists, long story short, I worked at some pharmaceutical companies and some plastics companies, and also I also did some environmental science. Yes, there's lots of stuff you can do with a STEAM degree. I'm just saying. Um, Lots of stuff that you can do with that. And so just keep that in mind. Like I said, this lesson, it's going to be fun because y'all know how I roll like. eh. Um, but our focus is fifth grade ish and up, as far as the terms and all that type of stuff. But the thing that we do at the very end, though, is going to be for everybody. Because you know I'm going to do something that is fun. It's good to do a little something. Okay, we'll talk about that. All right, so let's get into some terminology, people. Like I told you, solutions and dilutions. What is a solution? First of all, let's start there. All right, so a solution is a solid and a liquid. Okay, and a solid and a liquid together, where the solid has done what we call dissolved so much that if you put a solution next to, say, the liquid that the solution is made out of, they kind of look the same, right? It looks like it has disappeared. The solid, and I'll be demonstrating that for you. The solid looks almost like it has disappeared, like it's not there. You can't tell it's there until you start mixing it with another chemical. And then when we dilute, that means we take some of our solution and add more liquid. So it's less concentrated. Like I said, this lesson is friendly for like fifth grade up and ish. You see how I'm using lots of terms today? So let's write this down. Let's write it down. So a solution is a solid, and we call that solid a solvent or solute. And then we have a liquid. Today, our liquid for our solution is water. Believe it or not, you can do this stuff at home. You can go to the grocery store like right now, go grab materials, and come back home and do this activity. By the way, chemistry right in your home. I tell you. Hello. Hello, hello. Thank you for joining me. All right, so liquid is our solvent. Okay? Okay, so whenever you see these terms, okay, a solution, Instagram, I know it's backwards, but just bear with me, okay? So a solution is basically is a solid dissolved inside of a liquid. And then when you see these words solute and solvent, you know that they're just actually the parts of the solution. That's all it is. Okay? So let's go ahead and make our solution. We're making a baking soda solution today. Like I said, solution. It's a solid dissolved inside of a liquid, and dissolved means that it has mixed in so much so that it looks like the solid is no longer there. It's going to look like we just have water. All right, so we're going to start with some water. We're grabbing some water. Omar733, thank you so much for joining me. Hello. Hey. Don't forget to drop some questions in the chat so that I know that you're there. Facebook, make sure that I can know that you're there and that you can hear me. Hello. Very, very important. We've had some issues before. Not being able to hear me and whatnot. Test, test. 1, 2, 3. Alrighty then. Yes. So we are going to make a solution. Pretty simple solution today. And then we're going to observe and find out. I can roll up my sleeves. How y'all feel about the lab coat coming back? What? Yes, yes. Mm-hmm. Yeah. All right, so inside of my bowl, let's go ahead and do that. All right, inside of my bowl, I'm going to just put water. Could you? This is all it is. This is all it is right now. Then later, we're going to really get a chance to see what happens and how you'll be able to tell if a liquid is a solution, or if it's just a regular old solvent. So my solute is some baking soda. Baking soda. All right, just plain old baking soda that I got from CVS. Y'all know how I feel about CVS. I mean, yeah, you know that by now. I feel like you should know that by now. And I am just you're going to see me add it to the solvent, which was some water. You're going to see me add that. I'm going to mix it in. I need to mix it in thoroughly. One of the things that lets us know that we have made a solution is that it's no longer cloudy, right? So that the solvent completely mixes in. It might change the color of what we've mixed together, but it's not cloudy. That's how I know I have an actual solution. So a solution, as we went over earlier, is a solvent, as in the liquid, plus a solute, as in the solid. Stir, stir, stir. Stir, stir, stir. And still stirring. So I am mixing this thoroughly because it's actually quite important when you're working with solutions to make sure that your solid is completely dissolved. Now, while you watch me stir and all that type of stuff, just want to point out that I'm Miss Steph, in case you didn't know, and I am the executive director and founder of Triple F Empowerment Inc. We inspire, empower, and encourage young people to go into the STEAM fields, into the sciences, because the sciences are fun and cool and exciting. That's what we do. And definitely make sure that you subscribe to the YouTube channel and so forth. Yeah, now, here's the deal. I'm getting ready to make a dilution. You see there that I'm going to do a 50-50 dilution. So meaning I'm actually going to do 50 milliliters of my baking soda solution and 50 milliliters of the water. So you see here, I'm labeling my cup. Labeling is really important, like extremely. So always make sure that you label your cups and glassware and so forth. So here we go with the 50 milliliters of water into the cup. Now our 50 milliliters of the baking soda solution. Swirl. Now it's time to get to the nitty-gritty. Let's go ahead and see what happens when I start to mix this stuff together. With vinegar, obviously, because that's what we're doing. Baking soda vinegar reaction. Now, I need to do some labeling, of course, to make sure I know which cup has the original solution in it and which cup has the diluted solution in it. So I picked green. Shout out to our friend that was on Instagram who was participating and engaging. When you participate in the live sessions, you get to actually make comments and ask me questions in real time. And so that's why we used green for this particular session, because that's what the participant asked for. All right, so I'm measuring out my vinegar. Of course, you and I both know normally we would have it situated so that the graduated cylinder would be flat on the table, but it doesn't work very well when you're trying to show things on a camera. Rinsing out my graduated cylinder to avoid contamination. And now let's set up for our final. Here we go, baking soda solution. Rinse, rinse. Come on, Miss Steph, rinse. All right, we've got our dilution. I'm measuring it out. Again, I'm only holding it up for your purposes so that you can see what's going on. All right, here we go. Wait for it. Wait for it. Wait for it. There it is, the reaction we have been waiting for. Can you see the difference? Full strength solution has a bigger reaction because it has more reagent in it. There's more baking soda in the solution to react and create gas when it's added to vinegar. Isn't that cool? So there it is, that side-by-side comparison for you. It was still bubbling at that point, and the other cup had just stopped. It was barely fizzing. So I just want to say thank you so much for watching today. Please make sure that you like and absolutely subscribe and tune in on Saturdays. Peace.